Good morning. You're welcome to our pharmaceutical calculations BD 2253 lectures. Today we'll go into Aliquot measurement of volumes. In our last class we concluded Aliquot measurement of weights. Now we'll look at volumes. Hello. Hello. So in the Aliquot measurement of what? Volume. We just take a fewer step to measure the volume we want to measure. Unlike in what? In weighing. In volume, you don't have any business looking for the what? Least weighable, all those things here. Because once you look at the graduation or calibration of the what? Of the instrument. Good morning. Good morning. You will know whether you can actually measure the required volume with the what? With the what instrument. So that one doesn't really need, but it's the same principle. Is the same what? Principle of getting multiplying the volume you are asked to measure with a particular what? With a particular factor. When you do that, you now add a particular quantity of the what? The diluents, which you need to add. From there, you now take the volume that will contain the value, the volume you are asked to do what? Measure. So to avoid long stories, I will give us a question. So with that question, we can now solve this. Okay, before we start, I want to read out something. Listen carefully. Measuring volume by the what? Aliquot method. I'm reading from our course material. It says, the Aliquot method of measuring volume, which is identical in principle to the Aliquot measurement method of what? Weighing. They're identical in what? Principle. May be used when relatively small volumes must be measured with great what? Precision. The same thing if you are asked to measure a volume and the instrument you have, the measures you have, you cannot use it to measure the volume directly. So what do? You apply what? Aliquot method using the same principle. Here the first step is just to select a multiple of the desired quantity that can be measured with the required what? Precision. Select a multiple of the desired quantity that can be measured with the required what? Precision. Okay, number 2. Having done that, you dilute the multiple quantity with a compatible what? Diluent. You listen carefully. Listen carefully. Second step, you dilute the multiple quantity with a compatible diluent. Usually, a solvent for the liquid to be what? Measured to an amount evenly divisible by the multiple selected. Evenly. So there should be no what? Decimal what? Point. Are we together? It should evenly divide it. Have you now seen why I was running away from what? Decimal fractions. That is yesterday. Can you remember? So whatever you are dividing with, you should evenly do what? Divide it without giving you what? Remainder. I'm not complete because that will introduce it to make it to start approximating, which is not a good thing. Now, measure the aliquot of the dilution that contains the quantity originally what? Desired. The same principle. This thing I read now. We are doing not what we were doing that yesterday. Good. Now, let's look at this. Pick this question. Let's look at this question. The question says, a formula calls for 0.5 mils of hydrochloric acid. A formula calls for 0.5 mils of hydrochloric acid, full stop, using a 10 mil graduate. Using a 10 mil graduate, calibrated from 2 to 10 mils in 1 mil division. Using a 10 mil graduate, calibrated from 2 to 10 milliliters, in 1 mil divisions. Explain how you will obtain the desired quantity of hydrochloric acid by the Aliquot method. A formula calls for 0.5 mil of hydrochloric acid, full stop, using a 10 mil graduate calibrated from 2 to 10 mils in 1 mil divisions. Explain how you would obtain the desired quantity of hydrochloric acid by the Aliquot method. From this thing this question I read now, who can tell me the lowest measure, the lowest volume you can measure with this measure? Who can tell me the lowest volume you can measure with great precision? You can measure with this measure. Is what? Is 1 mil. Is what? 1 mil, because the saw is in 1 mil what? Division. So the lowest volume you can measure is what? 1 mil. That is the precision of the what? The instrument. True of us? Good. Now, if the lowest volume you can measure is 1 mil, now that they are telling you to measure 0.5 mil, what are you going to do? You cannot measure 0.5 mil directly using this measure. What will you now do? How will you now measure this 0.5? And this is what you must use. There's no other measures you have in your compounding lab. What are you going to do? That's the question now. You are measuring 0.5. That's what the question wants us to. The question wants us to find how you can measure that 0.5 mil using a graduate that can only measure lowest is what? 1 mil. How would I measure 0.5 mil? So remember the steps. The first is to multiply by a quantity, multiply by a factor to give you the at least if not equal to the lowest volume you can measure with this thing, or a bit above the lowest volume you can measure with what? This thing. With the what? The measurement. With the measure. Now having that at the back of our mind, also they told you something, that the graduate is calculated from 2 to what? 10. Now the first thing to do before you start is to try to have a clear picture of what the measure looks like. Draw it. Am I calculating using the description given? Now we are told that the graduate, let's assume is what? This is the what? Graduate. Am I communicating? You have something like this, okay? Let's assume that this is the what? The graduate. And we are told that it's calibrated from where? 2 to what? 2 to what? 10 mil. That means we have 2, 6, 2, 4. Good. That means we have 2. This is 2 mil. This is 4 mil. This is 6 mil. This is 8 mil. And this is what? 10 mil. Come in. This is what? 10 mil. 2, good morning. 2, 4, 6, 8, and what? 10 mil. They gave us another information that it has 1 mil division. If this is 2 mil, right? This is 2 mil. The lowest you can measure is what? 1 mil. So here you have what here? 1. You may not even put it. If you not even put it, you can just extend it here, or you can put it, no problem. You can put what? 1 mil. Here should be what? 3 mil. Here should be what? 5 mil. Here should be what? 7 mil. And here should be what? 9 mil. So this is what we deduce from the what? The description given to us. Now, with this now, you were told to measure 0.5 mil. Because there's no calibration here for 0.5 mil. If you try to use your eye, okay, you should be half. You commit error. So you cannot just go and start fixing. There's no it's not calibrated. So how will you do it? You can't use the eye and start fixing like you normally do. Okay, this should be half. If this is half, this place should be half. It's half now, and you not tell check half will be here. Come then say no. It's a bit above. Just use the eye to divide it into two. You are error. So it's not possible directly. The only way you can do that is what? Indirectly. That's the importance of what? Aliquot method. Now, how do we now measure this indirectly? You are told to measure what? 0.5 mil. The same way we multiply. Let's assume in our yesterday class, we are told to weigh what? 6.5. No, that one is a certificate. We are told to weigh 50 milligram, right? Yes. Yesterday we are told to weigh what? 50 milligram. And the least, the weight you can weigh with the instrument is what? Was what? Now here we are told to measure what? 0.5. But the least you can measure with accuracy, with good precision is what? 1 mil. The same way, hope you know that yesterday you can actually measure 80 milligram with this instrument, but there will be error. Yes. Up to 70%, true or false? True. The same way as you are doing your eye like this, you can decide and measure 0.5, but there will be what? Error. That error is what you are trying to avoid, because these things are what you are using. It's not the clothes you wear. It's not the clothes you wear. This is what you are using to produce drugs for human beings. So you should be very careful. Run away from error. Let it not be more than what? 5%. Am I communicating? Now, yesterday I'm comparing to so you understand what you are doing now. We are told to measure 50 milligram, but the least you can measure with good precision is what? 130. Today again, you are told to measure 0.5 mil, but the volume you can measure with good precision is what? 1 mil. What do we now do? Remember that yesterday we multiply this by what? By 9. By 9, right? And got what? 135 milligram. And we could weigh this, true or false? The same way here, what factor can we multiply this with? What can this can we multiply this with to get at least 1 mil or above 1 mil? Does it make sense? Does it make sense? You may decide to use 4. Okay? Okay. Let's use 2 and see what that will do. You know, sometimes you may use 2. You may use some. Like what you experience. You may come in. You may use a factor. Wonderful. You may multiply it and get the active ingredient. But when you now want to get the volume or weight that give you the aliquot, you're not able to do what? Do that. Let's try it and see what it will give us. Here is what? Good morning. Let's try 2. Let's try what? 2. If you do 0.5 mil times what? 2. It will give you what? 1 mil. 1 mil, right? So that means the diluents here, they didn't mention the diluent, so we can use water. Because under normal circumstance, you use water to dilute HCl, true or false, from concentrated HCl to what? dilute, use what? Water. They say water. True or false in the lab? Chemistry, right? Yes. Good. Now let's use water. But the best thing is not to just say diluent. See, they didn't mention the diluent, okay? Just say diluent. Now, so what you have there now is you have you use this measure to measure out 1 ml of the what? HCl, right? You measure out 1 ml of what? HCl. Then plus we don't know the volume of the diluent to put. And our target here is if you get 4 ml at the end, if you get 4 ml at the end, remember the factor we used to multiply, right? Yes. If you get 4 ml at the end, and if here is 1 ml, here is 4 ml, what should be here? 3 ml, right? Yes. So here becomes what? 3 ml. So let's divide through by 2 and see what we get. 1 divided by 2 is what? 0.5 ml. Plus 3 divided by 2 is what? 1.5 ml. Then 4 ml divided by 2 is what? 2 ml. So inside 2 ml of the diluent HCl mix, you have 1.5 ml of the what? Diluent and 0.5 ml of the what? HCl. With this, have we actually measured 0.5 ml HCl? Yes. Have we? Yes. Yes, we have. We have. Now, if you now want to prepare this, all you need to do is this. Sorry, is it divided by 2? What? Onya, have your lecture. She's confused. Onya, get her, have your lecture. Now listen. Good morning. Now we have 1 ml plus 3. Now what you do is this. Now to do the thing, simply do what? Measure 1 ml of the what? HCl. Then add what? 3 ml of the what? Diluent or water as the case may be. And mix what? Well, uniformly. If you get a homogeneous mixture, that is, you can't even distinguish between HCl and water again, they must be homogeneous. Now, if you get a homogeneous mixture, mix properly, you get 4 ml, right? Yeah. Then from that 4 ml, if you take 2 ml out of it, provided that you mixed well, properly, if you take 2 ml out of it, that 2 ml out of it will contain what? 0.5 ml of what? HCl and 1.5 ml of what? Diluent. So with this, you've actually done what? This one is simple, I said, because you don't need to go and start calculating sensitivity requirement. Apart from the issue of calculating the, what is it called? This way, because you know that one is for the weight, it's just a balance. So you need to, it's not calculated like this one. True or false? You need to use the sensitivity requirements given to you, and the error you should not exceed, and find the least weight you can weigh before you now get to this level. But for the volume, you go straight. Once you look at the calibration, you know that this one cannot measure below 1 watt ml. So if you do this way, you've actually what? Measured what? 0.5 ml of what? HCl. Instead of closing one eye and looking at it like this, trying to divide it into 2 to know the half. Maybe at the end, that thing you did may actually be 0.885, and you think is what? 0.5 ml. Someone like Kosi and Blessing may look at it, and they will see the different thing altogether, and at the end, it will be error, up to 200% error. So please, in that case, don't close your eyes. Once the calibration is not on the instrument, and let's assume you are working somewhere, and you are the one to prepare a particular solution, no matter this a particular preparation in liquid form, and you look at the calibration. Once you you don't see any it's not calibrated. It's not calibrated on the instrument, and you cannot. There's not else you can use there to do the measurements, and you have no choice. You must do this preparation. And those you are working for have no time for this long story. They are waiting for you to produce it. What are you going to do? You resort to what? Aliquot what? Method. You resort to what? Aliquot method. That's why you are trained. There must be what? A huge difference between you and some other people there doing what is it? Good. Onya, have your lecture. Can you do fufu? I will catch them one after the other. Ndi have a lecture. Ndi be late. I will catch them one after the other. What they ask is that I refer them as go. I ask.
Is it more that we must? Do we have to assume like this for now? You assume that
oh yeah, so again now. It's all the ask. I can all be a lecture and all be a no go. Yeah. Here, whatever you are fixing here, bear two things in mind. One is that whatever you are fixing here, fix something that if you take some point, like you cannot fix to here. Do you know why you cannot fix to here? Because if you fix to here, and the only volume you can measure out of here using this treatment is 1 ml. True of us?
Yes.
And if you measure 1 ml, this cannot contain 0.5 ml. 1 ml here will contain 0.25. True of us? So you cannot work. Then secondly, whatever you are fixing here, don't fix too much, so you don't waste ingredients. Am I communicating? Good. So these are things these two things you put into consideration. Don't go so low so that you can measure it out, and don't go too high so that you don't waste what ingredient. Most of these drugs or active ingredient, they'll tell you use 0.5 milligram. Most of them are potent active ingredient, and they're expensive. Most of these things you see, you use 0.25, if you trace them well, most of them are potent, and generally active ingredients are expensive generally. So you don't have anyone to waste for those you are working for, and say that you are working. At the end, you want them to pay you salary. When you are wasted, you are salary.
No.
Imana in Igbo language, ndị Igbo si na ebulozu onye ọ dịka ebukwu nkwa, because you are not the one. Those people that soon now you start working. People that it's not easy to establish a business. To be an entrepreneur, government is not giving you anything. You are the one that raised capital. Maybe you took loan from the bank, you sold your property, you sold your land, you sold a lot of things to start up a business, and watch the business grow, and you go and employ one human being. How are you? And you go and employ one human being. You say that he's a pharmacist or a pharmacy technician. He's there wasting ingredient for you. Those things na money. If I catch you,
I know what you can do.
that thing is money. If most of people that establish big business, most of them, some of them are even owing banks.
It's true.
Because of the loss you have accrued for the person. But they believe that tomorrow will be better. They believe that business will they will not say because I don't have money, they will close down. But even when they will pay salary, but they are owing a lot of banks because they want to flow the business. Now fuck up now. These things and this of Masco Limited. Tomorrow it just close. No, now they don't want it. They don't want it to happen. They keep keeping the hope alive that with time, and sometimes with time, business may boom and they recover all those things. There are sometimes they are even owing you. what they gathered, ingredient they gathered, you are busy wasting it. Then after you expect them to pay you. Don't worry. So with this now, you find out that you don't need to waste what? Ingredients. So get the one you need and get what? Going. Okay? Alright, so let's see if there's any other question here. Open it. If you're not watching, I'm more 2 seconds.
30 minutes now.
Alright, let's look at this question. This one. Okay, here they use. Okay, now, sorry, in reporting, please. In reporting, the same format. You do what? In reporting, you do what? Measure what? Measure what?
You measure.
Compare with what we did in the way. Measure what? See. See. How can you measure 0.5 mil? See. Measure 1 mil of HCl. Heading. Measure 1 mil of HCl. Dilute with what? With what? See. Dilute with what? Wait, dilute with what? Good. Thank you. God bless you. Dilute to 3 ml of what? Diluent. They didn't mention we know that you dilute HCl with water, but they didn't mention the diluent. Don't start stating what they didn't mention. Just say diluent, okay? 3 ml of what? Diluent. To do what? To make 4 ml of HCl diluent what? Mix. Measure 2 ml of what? HCl diluent what? Mix. So that this 2 ml of HCl diluent mix will contain what? 0.5 ml of what? 0.5 ml of what? Then let's assume that you want to measure the HCl you want to use for a formulation, for example. That means what it implies is that the diluent you use, listen carefully. Let's assume that you want to measure HCl that you want to use for a particular preparation. That means the diluent you will use in this aliquot measure should be the vehicle. Hope you know.
Yes.
Should be the vehicle for the what? Preparation. Even if it's not the vehicle, but the formula you want to use must contain what? HCl. Am I communicating? Even if the diluent is not the vehicle in that formulation, at least the diluent should be in the what? Formula. So what you now do is to counter what? Balance the volume of the diluent in this what? Mix. Subtract it from the one in the what? Formula. So that the ingredient will not be what? Excess. Am I communicating? The same thing we did in what? Weighing. So that the ingredient will not be what? Excess. If you use another ingredient as diluent that have no business with what you are formulating, you are creating your own formula. Whatever you are going to produce, I don't know what you call it, because it's not in the what? Formula. Then if you now use the ingredient in the formula as diluent and you did not counterbalance, it will become what? Excess. That one is under what? Issue. So these are the precautions you will take in using what? Aliquot what? Method. I have been shouting precaution because maybe in the sense that you see What precaution? See, precaution. You need to say precaution. Precaution. Hey, Sadaka. Hey, precaution. These are precautions you do what? When you are using what? Aliquot method. If you don't take these two important precautions, if you don't take them, you errors up and down. This one is even a word because you produce and nothing.
Please, that precaution.
Cheerful. Thank you. So let's look at this one. It says, let's look at this second question. It says a prescription calls for 0.2 ml of clove oil. Clove. CLOVE. A prescription calls for 0.2 ml of clove oil. Full stop. A prescription calls for 0.2 ml of clove oil. Full stop. Oil, yes. Using a 5 ml graduate. Calibrated in units of 0.5 ml. Using a 5 ml graduate. Calibrated in units of 0.5 ml. Comma. How would you obtain the required amount of clove oil using the Aliquot method? How would you obtain the required amount of clove oil using the Aliquot method? How would you obtain the required amount of clove oil using the Aliquot method? And alcohol as a diluent. And alcohol as the what? Diluent. And alcohol as the what? Diluent. So the active ingredient is what? Clove oil. The diluent is what? Alcohol. Now, I cannot clean the board, right? Huh? The first thing to do is to look at the what? The measure. Okay? Look at the measure. Try to understand the measure before you start anything. Don't just jump and start solving. Understand the measure first. Now let's have a sketch. Something like this. Huh? If you like. In my exam. In the exam. What's my own? Whether you draw, solve my calculation. That's what my. But this will help you out, not just here. Who said that? Hello. Wait. Listen carefully. I record this lecture. Be careful about what you say here, please. We are in a serious business here. We are not joking. I record this thing. The world is listening to you. Don't stay. I'm talking nonsense, please. If you are in this class, be focused and do what you're here to do. Am I communicating? Please. Even what I'm saying now is recorded. So be careful. Now look at this. Look at this. We are told that. Oh yeah, 1 second. Oh yeah, now 1 second. Okay, Mr. Opiel. All right, look at the question. Let's go back to the question. The question says, what we want to measure is what? 0.2 what? 0.2 mil of what? Clove oil. Then the next thing is that the graduate is 5 mil what? Graduate. Do you know what it means by 5 mil graduate? That the maximum capacity is what? The same way you have in your weighing balance, the maximum capacity. Hope you know. Can you remember? So the maximum capacity is what? 5 mil. Then, but it also says that the graduate is calibrated in unit of 0.5 mil. So the smallest calibration is what? 0.5. So the least volume you can actually measure directly without closing your eyes and opening your eyes is what? 0.5 mil. 0.5 mil. The minimum of what? Or precision, okay? Okay? Then this is what? Maximum what? Capacity. Now with this now, let us use this now to calibrate this. The maximum distance is what? 5 mil. And the minimum is what? 0.5 mil. So they didn't tell us, unlike the other one, in 2 to or 1 to. You don't need to be told that you should be 1 to 5, okay? Then in between 1, you start seeing what? 0.5, okay? That means you have this first. Say here is 1, here is 2, here is 3, here is 4, and here is what? 5. That means there should be what? 0.5 in between, right? Yes. Right? Yes. In between. So here is what? 1 mil. Here is what? 2 mil. Here is what? 3 mil. Here is what? 4 mil. Here is what? So that means here is what? Good. Start from me. Here is what? 0.5 mil. Here is what? 1.5 mil. Here is what? Good. 2.5 mil. And here is what? 3.5 mil. Here is going into 4.5 mil. Here is what? 4.5 mil. Now, but we want to measure 0.2 mil. That means somewhere here. Blessing. Can you remember? You get in your prayer. If we wear glasses, we know here. You don't know when your eye will come here. So don't even try to do that nonsense. Quietly use what? Aliquot method and get your answer straight. Now, so let's look at this now. We want to measure what? 0.2 mil. And the least you can measure with this is what? 0.5 mil. So we need to multiply this 0.2 mil with a factor that will give us something that will be equal to 0.5 mil or what? Above what? 0.5 mil. Let's start with 0.5 mil and see what we can get. Is there anything you can multiply this with? Look for a whole number, okay? Look for a whole number. 4. 4 times 0.2 mil is what?
5.
Huh? 5 is what? 1. Okay. Let's use 5 and see what it gives us. Let's use 5, okay? So 0.2 mil times what? 5 is equal to what? 1 what? Mil. Can you measure 1 mil with this? Yes. So let's work with what? 1 mil. So that means you measure 1 mil of what? Clove oil, right? Yes. You measure 1 mil of what? Clove oil. We don't know the alcohol we add. Let's work on this side. What do you think we can put here? 5. Do you try 5? Yeah. Huh?
No, if you divide
5 by 5, you get what? 1 mil. If you divide 1 mil by 5, you get what? 0.2.
Yes.
Then if you divide 4 by 5, you get what?
4 by 5. 0.8.
So let's use what?
5
mil. So if you use 5 mil here, that means what should be here? 4 mil of what? Alcohol. So that means, let's divide 2 by 5. Let's see what it gives us. 1 mil divided by 5 is what? 0.2 mil. 4 mil divided by 5 is what? 0.8 mil. And 5 mil divided by 5 is what? 1 mil. So actually, if you want to measure this clove oil, what you do is this. Using this graduate, measure 1 mil of what? Clove what? Oil. Then add 4 mil of what? Alcohol. And mix properly until you get a homogeneous what? Mixture. Now when you do that, from the blend, from the mix, you do what? You measure out what? 1 mil. Right? So that 1 mil you measure out will contain what? Will contain what? 0.2 mil of what? Clove oil. So if you now want to report, you write measure 1 mil of what? Of what? Clove oil. Dilute with what?
4 mil of alcohol.
Dilute with 4 mil of what? Alcohol. To make 5 mil of what? Clove oil. Alcohol what? Mix. Right? Then measure what? 0. What? Say. How can I measure 0.2 mil? Measure what? 1 mil of what? Clove oil. Alcohol what? Mix. So if you measure this 1 mil, it will contain what? 0.2 mil of what? Clove oil and what? 0.8 mil of what? Alcohol. So that means in this, if you are using alcohol, that means the implication is that if you are using alcohol to measure this using Aliquot method, that means the preparation itself, alcohol must be in the what? Ingredient. Hope you know. Alcohol must be in the what? Ingredient. Then before you now add the alcohol in that is in ingredient, you counterbalance. You subtract this 0.8 mil already in your what? Mix. True or false? Then you add the remaining alcohol, whether it is used as a vehicle or not. It doesn't matter. The most important thing is that you should do what? Add. That means before you start, that means you also consider one thing. Before you start, what if the alcohol in the formula you are using for the preparation, what if the alcohol there, the volume in the alcohol, let's assume that the volume in the alcohol is not up to 0.8 mil. What are you going to do? Up to 0.8 mil. The volume in the formula, alcohol in the formula you want to use. Alcohol in the formula you are giving for the preparation. The alcohol in the formula is not up to what? 0.8 mil. What are you going to do? That's why you should look at it very well before you start. So you know the amount of alcohol you use here. Okay? Am I committing? That means the amount of alcohol you should use, the amount of diluent. I am making a point, a rule now. A rule now. What will guide you on the volume of alcohol to see? The volume of alcohol, the volume of the diluent you want to use for Aliquot method. The volume of diluent, the volume or the weight of diluent should be equal to or less than the volume or the weight of the diluent you will need for the final what? Preparation. The one in the formula. It should be equal to, let me use this as an example now. You know here is 0.8 mil. Let's assume that the volume of alcohol in the formula, remember the first rule that alcohol must be in the formula, whether as as ingredients, other ingredients, or there as a vehicle. It must be what? There. Now, because here is alcohol, here is 0.8 mil. What it implies is that the alcohol in the formula must be 0.8 mil or less than what? 0.8 mil. Must be above what? Above 0.8 mil. It must be above or equal to. It must be equal to 0.8 mil or above 0.8 mil. You know why now? If it is less than, that means you are adding excess what? Alcohol. True or false? But if it's equal to, fine. You don't need to add another alcohol again. True or false? You don't need to do what? Add another what? Alcohol again. Then if, what does it say last? Someone should read that general rules. Someone should read it.
Of diluent should be equal or less than the volume or weight.
One person should do it.
The volume or weight of the diluent should be equal to or more than the given weight of volume.
Should be equal to
Or more than
given.
or more than the volume of the weight.
What will you
The volume or weight of diluent should be equal to or less than the volume or weight of the canister.
Hey! I wonder what the young to say. Who not copy also? I wonder what the young to say.
He said that it's not
Volume
common.
of diluent.
Okay, it's okay.
The volume or weight of the diluent in the formula.
Again.
The volume of the diluent should be equal to or above the volume or weight of the diluent in the formula.
Good. That's what. Please listen carefully. Read that. Read, please, hello. Please. Kedifu nu nede. Get on the first. Na nede. Ngwa.
The volume or the weight of diluent should be equal to
Good.
or
Equal to
above,
or.
or above the volume or weight of the diluent in the formula.
Good. That's what I want to correct. Please. It should not be what above. Hope you know. Look at it. Look at it. Let me explain. Don't just look up. Look up. Just look up. Why say oh? Look up now. Don't say oh. Have I gone? I'm here with you. You know me oh. Just look up first. So you grab it once and for all. Listen carefully. Read that again. Mass nonsense.
The volume or weight of diluent should be equal to or above the volume or weight of the diluent in the formula.
Okay, the volume or weight of the diluent used in Aliquot measurement. Please put it. It's important. You use in the what? Aliquot method. Please put it. Okay. The volume or the weight of the diluent used in the Aliquot what? Measurement. Okay. It's very important to do that. Put it. Should be what? Equal to or what?
Above the volume or weight.
We accept equal to. Should it be above the volume of the volume of the weight in the formula? Should it? From what you have described here since. Yes. Should it be above?
Yes.
Should it be above?
Yes.
Let's check whether it's true. She read something that the weight of volume of the diluent used in Aliquot measurement should be equal to, we agree with that one, or above the weight or the volume of the diluent in the what? Formula. The formula for the main formulation, compounding, okay? Now, we accept equal because if it's equal, you don't need to add extra what? Diluent again, right? Then, should it be above the one in the formula? It shouldn't be above. Because if it's above the one in the formula, you have already put it in the mix, you can't move it again. Hope you know. Are you aware? So if it's above, that means you are adding the excess of the what? Diluent in the formula. Okay. For what I said now, for what I said, that was a mistake. It was a mistake we are trying to correct now. We are going back to what was said. Me that stopped and asked her to read that again. That one is gone. Follow the one we are saying now.
Okay, so what are you saying now?
Okay, what am I saying now? Oh, So all this while, her mind is fixed in that one she wrote, and that one she will say, oh. If you like it, leave it like that. Enjoy it. I have been saying it here since over and over again, and her mind is fixed in that one out there. Nobody just say, oh, up and down. Do you like that one? Do you like it? Okay, it's clear some of you don't. Okay, let me use practical this to explain this. Let me use those that cook soup. Okay, those that cook soup, right? Raise your hand. Let me see you. Those that cook egusi soup now, raise your hand. Let me see. Or those that cook stew. Now listen. Hello, listen. I want to use what you do on daily basis to explain this. Nkucha nka una watazia. Emana egode. Now listen. You want to cook stew, right? And remember to see a pharmacy technician, a pharmacist, you see these people, pharmacy technician, they are supposed to be the best cook. For real, jokes apart. Compounding is nothing but what? Cooking. If you can compound well, for real, jokes apart, if you can compound well, take precautions of all these measurements, when to add this, quantity to add, and get the formula. Formula is your recipe. I hope you know. Those that cook, those that make snacks, the formula you use in compound is the same thing with what recipe you use in what cooking. The quantity of each of the ingredients. If you go to professional chef, and what quantity of Maggi you add, he will tell you it tastes professional cooking. If you want to cook professionally, each of these things have their measurements.
Yes, that's right.
For a particular quantity of food, listen. You are joking. Important things you're joking with it. For a particular quantity of food you want to cook, there's a measurement for each of them. Let's assume that Maggi, you knock cube as case maybe that is 2 in 1, right? What you plan in cooking your stew. NWC is talking what I don't know. Listen now. 2 Maggi, knock cube 2 in 1, right? Now, that's what you planned to use to cook your, because you alone or we have 2 in room, you want to maybe 2 or so as case may be. Now, you had already cooked what? Your chicken, right? Chicken, add all those things. You want to make it rich so that the taste will come out before you now add it in the what? Stew. Can the taste this year? Then you pack all those things in the what? Making your what? Chicken this thing, right? When you are done with that one, you test it. The thing is right. You've added a cube of nor in it when you prepared it. Come on, sir. Hello, are we together? You have already added. Your plan was to use a nor cube 2 in 1, right? Then, but you have added just a cube of it in the when you are making your chicken whatever. Then, after that, you now, when it's time to pour everything in the what? Stew, tomatoes and other things. Now, when you pour that thing, you now bring that nor cube, that one you plan to use. You remembered that you had already added a cube when you are preparing the what? So what are you going to do? You remove one, right? Yes. You remove one, right? Use only one because we had already added one. This is summary of what I've been explaining here since. Am I communicating? So the amount of Maggi, let's assume now you want to, you plan to use a cube or 2 cubes, but you added 1, or you want, it's okay. How many do I add here so that I will not exceed the amount I want to use? The final soup, the final pot of soup you want to cook is like the final preparation. But that chicken you prepare is like Aliquot measurement of whatever you want to do. Now, how many cubes do I add? Since I want to use 2 cubes there to prepare the stew. How many cubes do I add in this chicken so that it will not exceed? I said, okay, let me add 1. The one, will you go and add 3 cubes in the chicken when you want to use 2 cubes for the final for the stew? Will you do that? You can only add 2 cubes of Maggi in the chicken, or 1 or less than 2. So if you add 2 cubes, you don't need to add Maggi again when preparing the what? Stew, because the Maggi is already in the what? Chicken sauce. True of us? Good. You can only add 1 or that 2. Then if you added 1, you need to add only what? 1. This is summary of what I've been trying to do what? Explain. That's why I said, if the volume or the weight of the diluent used in Aliquot measurement should be equal to or less than the weight or the volume of the diluent in the formula. Period. That will guide you to know the amount of the what diluent should be, and this will consequently determine what you should do what here, provided that they can divide through and give you the amount you're looking for. So you check all these things. Are we together? Yes, sir. Good. So I don't know if there's any other question here. They ask.
So, sir, like if you are using this Aliquot method, like here you say that we should for us to avoid error, because measuring 0.2 mil here we cause error or greater percentage of error
directly.
So instead of us to use this measuring this and looking at it, we should find the whole number. Yes. That can be measured perfectly in this. So, sir, after we find the whole number that can measure perfectly, 1 mil, we found 1 mil. So what we do is that after doing this, like we multiplied all through by 5. So after this now, so everything, the final mil should give us 1 mil after dividing. Yes. Wow.
So after dividing,
Was the wow necessary?
You say after dividing, what are you saying?
Like as long as we can measure at 0.2 mil, the last one will give us 1 mil.
Yes. Okay. Alachasia ifa na alacha. Elube 40 years. Eza agụ n'ọnụ. Achọba eze achọ. A na-emezi. Lachabanu. Alacha aṅụọ sugar up and down. Lachabanu. All right. Any other question? Any question? Okay, now let's see if there's any other one we can solve here. We have actually dealt with this. I think the next place we'll go into what? Percentage what? Error. We'll go into what? Percentage error. Ask. No, this one. Onya! Una Fulonia. I think let's go to percentage error. I will just give the formula, then we'll take it up from there. Yes. Okay. Quantity to the decimal. If I be a sweet na cause. Us you know quantity to the decimal. Please keep it low, please keep it low. Keep it low. Victoria, who is Desmond? Keep it low. That's a topic for Fanda Day. She must tell us who is Desmond. 20 watts desired of blood Desmond. All right, down. So percentage error is error itself over what? The quantity. Before making a measurement, before taking a measurement, there's a particular quantity you have in mind to do what? Measure. Am I communicating? Yes. Good. You may end up not measuring that what? Quantity. You may end up measuring more or less. Now, that error is now that difference, okay? Between the error now is the difference between that quantity you have in mind to measure and the quantity you ended up measuring. The difference is what? The error. Now, if you now want to know the percentage error, is that error, that difference, which is the error, over the quantity you desire, you have in mind to measure, times what? 100%. Am I communicating? Yes. Good. At least we're talking about error in measurements. This is how to calculate the what? The percentage error. Any other question you will see under this may just be revolve around this, but they can be twisted around to confuse you. Once you follow what we'll be doing, there's no question you see in percentage error you cannot do what? Solve. Now let's see if there is a question here. Read. Thank you. In fact, come and write on the board, please. Be there on the board. All this read. They take all this read to take some time. Write it out so that we can take it up from there. From where? From the quiz. You're not serious. From here. Desmond is on the board. Keep quiet. Desmond is on the board. Keep quiet. Any question here? Huh? Are we finished with the examples? Is there no example here? Let's start from known to the unknown. Any question here? Just hello, please. Quiet, please. Don't know who is on the board and you're making noise. Quiet. Okay, the question says a prescription calls for 800 milligrams of a substance. After weighing this amount on a balance, the pharmacist decides to check by weighing it again on a more sensitive balance, which registers only 750 milligrams. Because the first weighing was 50 milligrams short of the desired amount, what was the percentage? What? Error. When you are done copying, let's solve it. Okay. the formula is what? Error is what? Error. Percentage error is what? Error over our desired. Now let me ask a question here. From this thing now, what do you think is the desired quantity? Okay.
It's 800.
China said the 750. China Alpha. Oh, 700 from where? Because yeah, who now said? Don't know. Because save a sister. Tony, I see her. Save a sister, seriously. Tony, I said because Kosi, please help her. Because can you say one is okay, now in the prescription you have 800 milligrams. If you saw the pharmacist nyana away, what you are told to weigh is what? 800. That is the desired what?
Wait.
Am I communicating?
Yes.
He now went and used a weighing balance that is not even. I don't even think that balance is still okay. Listen carefully. He first of all he used one balance to weigh it, and after weighing it, what he weighed was showing him 800 milligrams, the desired quantity. He was happy that he has actually weighed what? 800 milligrams, but he didn't know that the balance is not sensitive enough. On a second thought, he said, "Let me cross-check with another what?" So when he now used a more sensitive balance, he now realized that what he was carrying up and down was actually what? 50 milligrams, not 800 milligrams. So the error in that measurement is what? 50 milligrams. Am I communicating? So the percentage error is now what? Over what? Times what? The desired quantity, the desired measurement is what? 800. The measured quantity is what? So the error is what? 50 milligrams. So the percentage error is now what? 50 milligrams over what? 800. If you are not careful, you go and do 50 milligrams of what? 750 milligrams. What's the answer?
6.25%.
That is 50 milligrams over what?
Over 800.
Times what?
100.
Is it clear? Who said no? I am of credit about yourself. Kosi. Was he okay? You did what?
Like 800 on top and 50.
No. It's 50 above because the error itself is 50. Then some human beings will go and they call the error 70 milligram. Please, 70 milligram is the measured quantity. The desired one is what? 800. Is there difference that gives you the error? So note these 3 points. Note which one is the measured and which one is the desired, and know which one is the error itself, and know which one is the percentage what? Error. Once you know these things, there's no question. You will see under percentage error, you will not be able to do what? Solve. We'll end this topic with percentage error. Next time we'll see again is we'll start our what? Our fifth. Next time you see me in this your class, we'll start the 5th what? And that next time is 7:45 a.m. tomorrow. We still have like I'll leave here by 9:45. So we still have like roughly. Yes, now. It's not. Okay, sorry, 10:30 up, yeah? We are showing others. Some people are there. Some people are reading. Please, let me proceed. What is the issue now? No, leaving, it's not leaving the class. When you conclude prayer, do you leave the presence of God? No. You are still there, right? With the presence. Here now, I'm still here. We are done with presented error. I want to check, let me know whether I'll enter the next topic. So what do we use remaining? Okay. So today time is what? 9:14. So I will leave by 9:45. 9:40. 45 minus 14 is what?
30 minutes. No.
Okay, 30 minutes time out. So what can we solve under 30 minutes? Get it, let me see. Huh? You say what? Ask now, feel free, ask.
What if I give you the active you use our numbers, you use water.
If you are giving what?
The active ingredient, we are not doing anything to solve it.
There's no way. Okay, just for calculation purpose, just say diluent. Don't mention, because you just say diluent. Diluent. No, because you can't start saying what you were not giving. Just say diluent. That one will cover the whole thing. Diluent.
But there must be a diluent.
Yes. Yes. Even if it wasn't given, just say diluent. It's okay. Measure blah, 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 make dilute with blah, 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 diluent. Yeah, you are good to go. Then another thing you will do is when you go, you are given diluent, specific diluent to use. You are given specific active ingredient to use. Then you come and say measure so milligram of active ingredient and dilute with dilute. You're on your own. You must call their names. Call what? Their names. Because you are given a named active ingredient and they named what? So these are the things you watch out. Okay? These are it. Unless you're not giving. There are some questions like that. You can say drug, calafia, diluent. It's okay. It will be marked. If there's any question, we have 30 minutes to go. Any other question, bring it down. Let's solve. Go and write it on the board. When she's done, you go and write your own. Now look at this. The question says, take down sodium citrate 5 gram, tartar emetic 0.015 gram, cherry syrup 120 ml. Using a balance with sensitivity requirement of what? 4 milligram. An acceptable weighing error of what? 5%. And the cherry syrup as what? Solvent for the tartaric emetic. How could you obtain the correct quantity of tartar emetic to fill the what? Prescription. From this formula, tartar emetic is 0.015 what? Gram. In this case now, you don't need to be told that all this is a long story. They just want you to do what? check how you can weigh this what. Please, hello, please. In any question, learn how to pick the important points you need in your what calculation. Okay? Learn how to sieve information you don't actually need in your what calculation. Okay? Good. What we need here now is to SR. Use our SR to find the least weight you can weigh. So we use our SR, which is 4 milligram, and the acceptable error, which is 5%, to get the least what? The least weight you can weigh without causing error above what? 5%. Alright, do it now. Target it. The least weighable weight. The least weight you can weigh with this instrument without causing error above what? 5%.
80 milligrams.
Do it now and let me know. Someone say 120. Who's that? You know where one? Okay, so let me clean the board. We are done with this one, right? All right, let's see. Oh yeah. So that means LW. Remember, LW is what? Is what SR over what? Times what? So this is now SR is what? 4 milligram over A is what? Times what? Hey, I'm making noise in this class. Who is that woman making noise in the class? Chinaya, Diaba, Abia. Oh yeah, go to the stream. You, Meadow. Maybe I'll start separating these 3 human beings in this class. They are what noise generators in this class. 3 of you, and they're in the same room. Actually, we'll take one. All right, let's go now. We have what? So the answer is what? 80 milligrams. So what it means is that this 80 milligram is what you can weigh. The minimum you can weigh. If you try to weigh anything less than 80 milligram with this weighing balance, you commit what? Error above what? 5%. So to avoid that, simply weigh 80 milligram or what? Above. Are we together? Now, they want us to use this weighing balance to weigh what? 0.015 milligram. Convert this to gram, Convert it to milligram so that they will be the same units. The weight of this tartaric is what? So you multiply by 1,000, right? Yes. So that means what you want to weigh is what? 15 milligram of Tata emetic. Okay, now, but this is what you are asked to what? Weigh. But this is the minimum that this thing can weigh without causing what? Error above what? 5%. So what do you now do? Huh? How I got it? Is the question now? This is a formula. This is a formula for a preparation. Can you get some money? Okay, tell me, what are you doing?
I was copying the other.
Okay, you jumped here. Okay, now. Hello, now. So we want to weigh 50 milligram, right? But the least you can weigh is what? 80 milligram. So what you know, the first thing now do is, this is actually yes. Now look for a factor that you can multiply with to get either 80 milligram or what? Above. Are we together? So should we target 80 milligram or above? If you target 80 milligram, that means you multiply 15 by what? Okay, let's make it above, right? So let's target what? 90, right? 150 milligram times 9 times what? 6 is equal to what? 90 milligram. So that means you weigh 90 milligram of the what? It's equal to active ingredients. Same what? Tartar what? A metric. So we weigh 90 milligram of what? Tartar a metric, right? Then we don't know diluent. The diluent there is what? Blessing. All right, so we don't know. We announce, okay, this is 90 milligram of what? Tartar what? A metric. And diluent here is what? Diluent here is what? Cherry what? This thing now I like this question. I use it to explain that thing I was talking about since. This is formula for preparation. But you need to weigh out this thing first. Using you need to use cherry syrup. What they say, sorry. Using as what? Using cherry syrup as what? Solvent for what? How could you obtain the correct quantity of tartar metric to fill the what? Prescription. Okay, here now. This one is somehow. Do you know why? Cherry syrup is in milk. No, I'm coming. Okay? What we doing since we do what? We change. See what you do. See what you do. See how we do it. You will stop at this level now. Yes. Okay? You multiply this by 6 to get the one you can weigh, the amount you can weigh. You stop at this. So this 90 milligram now, you can weigh it out. But if you weigh this 90 milligram, and add, let's assume you weigh this 90 milligram now, and dissolve, put it in a beaker, or let's say you are conical measures for dispensing, okay? Am I communicating? Then you add small of this, you add this, put this now, add small of this cherry syrup. Am I communicating? Then dissolve it small amount. Then you keep adding cherry syrup until you get up to maybe, let's say, any volume of your choice. Am I communicating? Let's say you get like 100 ml, for example now. Let's say you add like 100 ml of what? Cherry syrup, or even 90 ml of what? You can use 90 ml of. It's no longer 90 ml of cherry syrup now, of the solution. Hope you know. Because you added small. You mark 90 ml in your bottle, right? Then add small of the cherry syrup, dissolve the dissolve it. Then maybe after dissolving it, to form a solution at this level, you then pour more of the what? Cherry syrup, so that the final everything will be what? 90 what? ml. Everything will be what? 90 ml. The entire solution will be what? 90 ml. Remember that the amount of cherry syrup inside there is what? 90 what? Milligram. Are we together? The amount of cherry syrup inside there is what? 90 milligram. Then with this now, you are preparing a solution with a concentration of what? 90 what? Milligram over what? 90 what? Ml. Are we together? Which is now saying 1 milligram per what? Ml, right? 1 milligram per what? Ml. So that 1 milligram per ml, what it means is that 1 ml of what you prepared contains what? 1 milligram of the what? Tartaric acid. Tartar-emetic. So if you need 15 milligram of tartar-emetic, you just take what? 15 what? Ml of the what? Are we together? Of the what? Solution. This 15 ml of the solution will contain what? 15 milligram of what? Tartar-emetic. So that thing you prepared, you just take 15 ml from it. Bam. And once you take 15 ml from it, you have taken what? 15 milligram of what? Tartar-emetic. You keep it. This is tartar-emetic. Inside that solution is 15 milligram of what? Tartar-emetic. All you need to do is this. Weigh 5 gram of this. Okay? Weigh 5 gram of this. And add inside that 15 ml. Okay? That 15 ml that contains what? Tartar what? That contains 15 milligram of what? Tartar-emetic. Measure 5 gram of this and add inside it. Mix it. Then add more of this cherry syrup until everything get to what? 120 what ml. If you do it, you have prepared. Anyway, I'm not supposed to be going into preparation, but it's good that I talk about it so you know it. You have prepared 120 ml of the what? The entire what? Solution. But what you need is that thing I did. You get 15 ml. If you get 15 ml of it, you have taken what? 15 milligram of what? Tartar what? You mustn't be 90 ml, hope you know. You can use 20 ml if you like. Let's assume you use 20 ml, but it will be highly concentrated. Let's assume you use 20 ml. You have 90 milligram over what? 20 ml. We have what? 4.5 milligram per what? Ml. Now, if you now want to get something that will give you 50 milligram, it will enter into what? Fractions. True of us. So the best thing that will give you what you want is what will give you a whole number. Okay? That's why I chose this. So that 1 ml is 1 milligram of what? Tartar-emetic. So if you want to measure 15 milligram of what? Tartar-emetic, just take what? 15 what? Ml. Just take what? 15 what? Ml. Are we together? Once you take 15 ml, you've taken what? 15 milligram of the what? Tartar what? Emetic. Okay? Ask a question if you have a question. Put what down? I should put what down. How? You say what? Yes. Which one? Where I got times. Hey, I listen to Elizabeth. Hello, please. Don't miss your lectures for anything. Don't miss your lectures for anything. To be personal, I still don't know what will make a student to be missing his or her lectures. Anybody that knows should let me know, because me, I don't know what is that thing. You are sick. I told who that you are sick? To who? You forgot to. Why didn't you call me on phone? Now, please, I beg you, name of God. Please, I beg you, name of God. Please. Each time you miss class, you are putting the class at a what? Standstill. Because you keep going to, fro, to, and no lecturer will stand there, see you confused, will be happy. Am I communicating? No lecturer will stand here, see you confused, will be happy. He may not talk, but he's not happy. He may be angry with you that but he will, inside, he will not be happy that you are not following the class. Where do I even start from now? Do I start from the first of it? No, I don't start from now. That's please, someone should help her. I don't know where to start from now. We've met our 6 times. Anyway, the point is this. Look up, let me see how I can go. You know where we got 15 milligram, right?
Yes.
We cannot weigh 15 milligram using this weighing balance. Anything? I said we have here 15 milligram is what we want to weigh. But the weighing balance, you know how we got this 80 milligram, right? Can, without committing error above 5%, can weigh 80 milligram or above. Okay? Before you, because the only way you can do this cherry syrup is in liquid form. The only thing you can do this is to dissolve, form a solution of this tata emetic with what? Cherry syrup. Some volume of cherry syrup and form a solution. So that if you take a particular volume of the solution, you have taken some milligram of the what? Tata emetic. Now, we decided to multiply by 6 to get 90 milligram. So you can weigh 90 milligram here. Even if you like, you must be natural. If you need, you can simply weigh the same 80 milligram. This is not even necessary again. Are you aware? I was doing it because I was thinking that our diluent is what? Solid. When I realized that it's not solid, this times 6 is not even necessary again. You can simply just weigh, take the amount you can weigh with the what? Weighing balance. You can simply, if you like, you can just weigh 100 milligram of it. Take volume of what? Specific volume of this syrup and form a solution with it. You must be up to 1 to 2 minutes. You can take 200, you can take any amount. But as you are doing so, be careful so that you take amount that when you now want to measure out the volume, it will be easy for you. There's amount you will take. The ml you will measure will start giving you 2.73 to 2.1333 ml. Then you start approximating. So it's better you get something that you can easily measure out the ml without giving you fractions. That's why I chose 90 ml. So that if I divide 90, concentration, if you want to know the concentration of this inside, with the ratio now, there are 90, what it means that there are 90 milligram inside 90 ml of solution. This 90 ml is not the volume of cherry syrup, it's the volume of the entire what? Solution. That's why I said you should put small, you put the 90 milligram of the what? Tata emetic inside this measure. Then add small amount of the what? Cherry syrup and dissolve it. Then you mark at this 90 ml level. You keep adding the cherry syrup, dissolving until you get to what? 90 ml. That is, the entire solution is what? 90 ml. That's why the 90 ml of the solution contains 90 milligram of the what? Tata what? Emetic. So if 90 ml of the solution contains 90 milligram of what? Tata emetic, how many ml will give you 50 milligram of tata emetic? Answer that question. 1 ml. Good. If 90 ml contains 90 milligram of tata emetic, you will need to take 50 milligram. And it's only this solution that can deliver the what? 50 milligram. So how many ml will deliver 50 milligram? 15 ml. So if you take 50 ml of this solution, I know that this thing will confuse some people. I know, because we are not on concentration, but it's a common sense at this level. Because if you cancel out, if we have 1 milligram per 1 ml per ml. So if you take 50 ml from this, it will give you what? Now, so you just, that thing you prepared, what you need here is just 15 ml. Take your 15 ml and go your way. If you take 15 ml from this, then you have inside the cup holding 15 ml of solution contains 15 milligram of what? But it's now in solution form, no longer what? Solid form. Because even if you can measure this tata emetic, even if let's assume here is 2 grams, you will still dissolve it. Hope you know.
Yes.
Are you aware? Yeah. So, but we are going to dissolve it here to get 15 milligram. That 15 milligram is now in solute inside the solution. You form with what? Cherry syrup. Now, let's assume now you have done your Aliquot measurement. Let's assume you want to now, how you will now incorporate this, where you want to now do your preparation in case you enter your lab. What you do is this. Just get weigh 5 grams of what? Sodium citrate and dissolve inside this place. If you dissolve it there, this liquid, am I communicating? Or if the liquid is too small, you pour small of this to get enough volume. Then you now get 5 grams of this, add there, dissolve. Then you mark 120 ml here at your new measure you want to use to do what? Compound it. You mark 120 ml. As you dissolve it, you keep pouring the cherry syrup until you get to what? In that case, you have prepared 120 ml of this. It shock you?
No. Yes.
Is it clear?
It's clear.
Call my Kabiko. Call my. Is that what?
Since you've done 120 of the solution, what's the correct quantity of data you're mixing? Is it
15 ml.
If you do what?
15 milligrams.
You said that you mix, you keep mixing, mix up to 120 ml the solution. How many is data you're mixing?
If you like, pour 1,000 ml of the solution. That I may take inside there is 50 milligrams. It can't change.
Because of 15 milligrams.
How do you get it here?
Yes.
You can't change.
Yeah, okay, so write it in. Okay, meaning that side is not necessary. 90 milligram plus dash.
No, it doesn't necessarily. That one, had it been the dialect is a solid form. That's where that one will work. I started doing that. Do you know why I checked? Do you know why I checked the question again? Let me be sure that here is what? Male, not what? Here is gram, milligram, not male. That's what I checked. Okay? But when I checked it, I found that it's male. That's why I now went to another what? Method. So play with these things, okay? Which question? That one. Okay, oh yeah. I think our time. Oh yeah. Write the fast one. Let's stop and go. We end up. We end it here. They are not concerned students at the public method. I just started talking about. Let's assume you are going to do the operation in the lab by yourself. After getting the 15 ml that will contain 15 milligrams, you can, if you now want to now proceed with what the preparation, how you will now prepare it. That's why I started saying you add sodium citrate, then add cherry syrup until you get to 120 ml. But the question wants to be just how to measure, how to get your 15 milligrams. That's what the question asks you. Which stops at taking 15 ml of the what? Solution formed by cherry syrup and what? Tata what? In it. Is it clear?
Saying that 15 ml. 15 milligrams. 15 ml.
It's equal to? Inside 15 ml.
Can you say that 15 milligrams?
No, it's not 15 milligrams per ml. It's 15 milligrams per 15 ml.
Okay, 15 milligrams per 15 ml. It's not 15 milligrams per ml.
And that's why even if you still divide it, it will still give you the same concentration, 1 milligram per ml. True or false? If there are 90 milligrams in 90 ml, there will also be 15 milligrams in 15 ml.
But when you say that even if you raise it to 120 that only contain
if you like, pour water here, pour the syrup to be 1,000 ml. This cannot change because what you actually weighed is what? 90 milligrams. The solute you added in the solution is constant. If you like, go and get GP tank, measure salt, measure 2 grams of salt, and pour inside that GP tank, and keep pouring water to get to how many liters. When you are done, the amount of salt in the GP tank will say be what? 2 grams. If you like, pour only small amount of water. The amount of salt is what? The same what? 2 grams. But what will change is the concentration. Don't worry, when we enter concentration, you understand it better. Okay? Amount and concentration are not the same thing. Okay? I think we have done justice to this. Now let's solve this question and stop it at that. a graduate weighs 35.825 grams. A graduate, what you are using for what? Weighing. Okay? When you weigh only that graduate, it gives you what? 35.825 grams. But when 10 ml of water are measured in it, the weight of the graduate and water is what? 45.835 grams. Calculate the weight. Calculate the weight of the water and express any deviation from 10 grams as what? Percentage what? Error. Now, listen carefully. Hello. If you want to know the weight of a liquid, just get an empty vessel, empty beaker. Weigh the empty beaker alone and record the weight. Then pour that volume of liquid you want to measure its volume inside that beaker. Weigh again. It will give you a new weight. Then you subtract the weight of that beaker and that contain water from the weight of the beaker when it has no water. The difference in the weight will give you the weight of the water you added in the what? Beaker. Simple. Now, if you want to know the weight of water here now, the graduate alone is 35.825. Graduate alone is 35.825 grams. Then the graduate plus water is 45.835 grams. Therefore, the weight of water added, that 10 ml of water you added, the weight is what? 45.835 minus 35.825, which is what? 10.01 grams. This is the weight of the water. That 10 ml of water that was added, that's the weight. So we have calculated the weight of water. First part answered. Second part says express any deviation from 10 grams as percentage of. What is deviation? Deviation, difference between this and 10. How this thing differ from 10 grams? Simple. So subtract 10 grams from this. So the deviation is what? Deviation is what? 0.01. This deviation is an error. Deviation is the error. It shock you? That's the error. So that's what you mean by deviation. Okay? You know I told you that question can be twisted in any form. Your own is to once you you brace it short. Easy, no, yeah, easy. Make it easy. You hearing me? So the deviation is what? 0.01 gram. That's the deviation, right? Now, which is the error? Now, what is now the percentage error?
0.01
divided by what? Divided by 10. Okay. Where is the actual weight? The actual weight. The desired weight. See, the person doing this, what he want to, the target is for 10 grams. So the desired weight is for 10 grams. So the error is what? 0.01 over 10 grams. 0.01 gram over 10 grams times 100%. That's the error. So what's the answer? 0.1%. That's the error, 0.1%. Even though it's acceptable, right? But it's still an error, you know. 0.1. Put more wheel in there. How much? I think we'll stop here for today. Yes, we have tried. The time is 10 o'clock. We have tried for today. We'll stop here. Any question? Any question? Any question? No. Please, from tomorrow, we enter the 5th quiz from tomorrow. And as we are doing the quiz, I'll divide the time into 2. We'll do quiz. Our next topic will start immediately. That same tomorrow. I'll divide my time with you into 2 equal parts. The other part will be for the quiz. Then the other part will be for the what? For the teach. So we are entering. What is the 6th topic? So we're entering dosage calculation tomorrow. Tomorrow we enter dosage calculation. That same tomorrow we will start our 5th quiz on pharmaceutical what? Measurements. On pharmaceutical what? We are done with pharmaceutical measurements. So tomorrow we'll start with the quiz. All right. Thank you very much for your attention. God bless you.